So, you know how we have these two incredible theories about how the universe works? Well, the problem is they just don't get along at all. They fundamentally contradict each other. But what if the solution, the key to uniting them, was to rethink the one thing we all take for granted, time itself? That's what we're going to do. We're going to build a bridge across the biggest divide in modern physics, all based on a wild new theory that completely redefines what time really is. Okay, so on one side of this huge canyon, you've got Einstein's general relativity. This is the stuff that deals with the big picture, right? Planets, galaxies, black holes. And in Einstein's world, time is, well, it's flexible. It's like a river that gravity can bend and warp. I mean, a clock near a black hole literally ticks slower. Then, way over on the other side, you've got quantum mechanics, the world of the incredibly tiny. And in that world, time is the complete opposite. It's like a super strict universal metronome, just ticking away at the same exact pace for everything, everywhere. No exceptions. So, how can both of these possibly be true? How can time be a bendy river and a rigid metronome at the same time? I mean, that's the question, right? It's the puzzle that's had physicists scratching their heads for almost 100 years. Both of these theories work perfectly in their own domains. They're wildly successful. But when you try to put them together, they just break. They seem totally incompatible. All right, so here's our game plan. We're going to build a bridge, piece by piece, to connect these two worlds. First, we'll get the lay of the land, then we'll construct 4 huge pillars: the quantum clock, gravity's echo, the cosmic stretch, and a really mind-bending one called gravity from information. And once those are up, we'll see how it all comes together to form one solid bridge between these two realities. Okay, first up, 2 lands, 2 times. Before we start building, let's just take a moment to really look at the chasm we're trying to cross here. Think about it. On one side, you have this smooth, elegant, almost predictable universe of Einstein's gravity. And on the other, you've got this fuzzy, jumpy, totally probabilistic world of quantum particles. It's like they're not even speaking the same language. And like we said, the biggest point of conflict, where their languages just completely fail to translate, is all about one thing: time. So if we're going to build this bridge, that's exactly where we have to start. All right, that brings us to our very first pillar, the quantum clock. This is so cool. This is where we're going to forge the first link between the time that you and I actually experience, our personal time, and what's happening way down in the quantum realm. Okay, so first, we need a concept from Einstein's world called proper time. It sounds complicated, but it's really not. It's just the time that's measured on your own personal wristwatch as you move through the universe. You know that famous idea where if you fly off in a spaceship really fast and come back, you've aged less than your friends on Earth? That difference is because your proper time, the time on your watch, is unique to your own journey. Now let's jump over to the quantum side of things. Turns out, every single quantum particle has this little property called its phase. And the best way to think about this is like it's the ticking hand on a tiny internal clock that every particle carries with it. It's just constantly spinning, keeping the particle's own unique rhythm. And here it is. This is the first connection, the first plank of our bridge. This new theory proves that a particle's quantum phase, how much its tiny internal clock has ticked, is directly proportional to its proper time. So what does that mean? It means the time you experience, the time passing on your watch, is literally just the grand total of all the tiny quantum clocks and all the particles that make up your body, all ticking away together. Our personal time is quantum time. They're the same thing. Okay, pillar 1 is locked in. We've connected our personal experience of time directly to the quantum world. Now let's move on to pillar number 2, gravity's echo. This is where we're going to look at how gravity messes with time, but in a totally new way. So, we all know from Einstein that gravity slows down time, right? And this isn't just some abstract idea. We have actually measured it. Scientists have put super accurate atomic clocks at sea level and on top of mountains. And sure enough, the clock on the mountain, where gravity is just a little bit weaker, ticks ever so slightly faster. We call this gravitational time delay. Okay, so what's the quantum version of that? Well, when a particle interacts with something, say a gravitational field, it gets delayed a little bit. A great way to picture this is like an echo. You send out a sound, and you time how long it takes for the echo to return. In the quantum world, this echo time is a really precise measurement, and it has a fancy name, the Wigner-Smith group delay. But really, just think of it as a scattering echo. And bam! There's our second pillar. This theory shows that the big-scale time delay from gravity is mathematically the exact same thing as this tiny-scale quantum echo. Think about that for a second. It means that Einstein's incredible idea of gravity bending the fabric of spacetime is just another way of saying the universe is changing the timing of quantum interactions. They're not two different things. They are two sides of the very same coin. All right, we're making great progress. We've connected personal time and gravity's effects to the quantum world. For our third pillar, we need to zoom way, way out, to the scale of the entire cosmos. How does the expansion of the universe itself fit into all this? Let's dive into the cosmic stretch. So, when astronomers look at galaxies that are super far away, the light from them looks redder than it should be? That's called cosmological redshift, and it's the biggest clue we have that our universe is expanding. The idea is that as space itself stretches, it stretches the waves of light traveling through it, making them longer and, well, redder. And this is where Pillar 3 comes in with a stunning connection. The theory proves that the amount of that redshift we see is identical to the change in a photon's phase frequency, basically the speed of its little internal clock. It's the ratio between how fast that clock was ticking when the light was emitted billions of years ago and how fast it's ticking when it finally reaches us today. So get this, the expansion of the universe isn't just stretching space. It is literally the stretching of a universal quantum timescale. Okay, so we have 3 really solid pillars now, all connecting time to the quantum world. But this fourth and final one, this is the most radical idea of them all. This one doesn't just give us a new way to look at gravity. It asks us to question what gravity fundamentally is. Seriously, just let this next question sink in for a second. We're always taught that there are 4 fundamental forces of nature, and gravity is one of them, right? But what if it isn't fundamental at all? What if gravity is something else entirely? Something that just emerges from an even deeper rule about how the universe works. To get our heads around this, we need to talk about something called generalized entropy. Now, you've probably heard of entropy as just a measure of disorder or randomness, but in physics, it's really a measure of information. It's about how many different ways you can arrange the parts of a system. So, this theory takes that idea and applies it to some imaginary boundary out in spacetime. And it says the total information, the total entropy, on that boundary is made of 2 things. First, the area of the boundary itself, that's like the geometric part. And second, all the information contained in the quantum fields just outside that boundary. And this leads to the absolutely mind-blowing punchline for our 4th pillar. The theory shows that you can derive all of Einstein's equations for gravity from one single simple idea, that the universe is always trying to maximize this total amount of information. So gravity isn't a fundamental force that pulls things. No, it's an emergent phenomenon. It's just what happens when the universe organizes its information in the most efficient, most statistically probable way. You know how heat always flows from a hot object to a cold one? It's not because of some heat force, it's just pure statistics. Well, this theory says space-time bends for the exact same reason, because it's the most likely way for the universe to arrange all of its information. And there we have it. We've built our 4 pillars: the quantum clock, gravity's echo, the cosmic stretch, and this wild idea of gravity from information. And with all 4 of them standing strong, that huge chasm between the quantum world and the world of relativity, it's just gone. We finally built our bridge between worlds. So let's just step back and look at what we've built. This is where it all clicks together so beautifully. Every single one of those classical ideas from Einstein's world now has a perfect quantum partner. Your personal proper time? That's just the quantum phase of your particles. The way gravity slows down time? That's the quantum scattering echo. The redshift we see from across the universe? That's the changing ratio of a photon's quantum clock speed. And gravity itself, the grand architect of the cosmos? It's simply the universe maximizing its own entropy. See? It was never 2 different worlds after all. It's one single reality. And now, we might just have a language that can describe it all. Look, pulling this off, creating this unified picture, it's a monumental achievement. But it also leaves us with an even bigger, more profound question to chew on. If time and gravity, 2 things we thought were absolutely fundamental to reality, turn out to be just side effects of how quantum information behaves, then what else is? What other parts of our universe aren't really things at all, but are just patterns emerging from something deeper? What other secrets are waiting for us, not out there in the fabric of space-time, but hidden in the pure, abstract flow of information?